Hello everyone, welcome to Terraform with GCP session 7. In this particular session, we are going to discuss about count and for each. What are count and for each? Count and for each are called as meta arguments in Terraform. These meta arguments allows users to create multiple resources from a single resource block. We will see the practical demo session as well. Just wait for a few minutes. As discussed earlier, count is a meta argument in Terraform which allows users to create multiple instances of the same resource. Okay. Below is the syntax of the count. If you see here, I have mentioned count equals to some number. Always remember, count always takes numerical integer value as the input. If you see the below line, I have kept count equals to 3. So it will accept 3 as the numerical integer and it will repeat that particular resource 3 times. Okay. What is the best use case for using this count meta arguments means when we are creating identical resources. Suppose I want to create 3 buckets of similar configuration at a time. I can go and use this particular count meta argument. If I want to create 5 virtual machines at a time of same configuration, I can use this count meta argument. And also using this count meta argument, we can avoid the duplication of the code. Means instead of writing the code again and again, simply we can use this count meta argument to loop in that particular code using count. So this is a sample example for showing the demo of a count meta argument. If you see here, there is one resource block. Resource block always starts with a resource keyword. After that, I am going to create one resource called storage bucket. That's why this resource type is Google underscore storage underscore bucket. After that, this is my resource name, my bucket. In open brace and close brace, I have included my arguments. First, I have included my count meta argument, that is count equals to 3, means it is going to create 3 buckets in the GCP cloud platform. And what is my name of the bucket? I have kept my name of the bucket in double quotes in this particular format. My underscore demo underscore bucket. After that, immediately, I have passed count as the input here with the help of a index, count dot index. So always remember, index starts with 0 and it will repeat till that particular count. So here it will start with index 0, it will loop from 0, 1 and 2 since count is 3. If you see this particular output of this resource block here, the output is shown as demo bucket 0, demo bucket 1 and demo bucket 2. Since my count is 3, 3 buckets are created as the output and each index starts with a number 0 and it will incremented by 1, 0, 1 and 2. So index starts with 0 and it will loop through n minus 1. If my count is 3, 3 minus 1 means 2. So the index will start from 0 and it will ends with 2. This is about the sample explanation of the count meta argument. So this is a basic summary here. See here, count takes integer value as the input. So we know that one already. So here count equals to 3. So 3 is my numerical integer. Next, count will create n copies of that particular resource. Since my count is equals to 3, it will create 3 storage buckets. That is also fine. And it will be indexed from 0 to n minus 1. So my count is 3. So n minus 1 means 2. It will start from 0. It will till loop through 2, 0, 1 and 2 as explained in the output. Demo bucket 0, demo bucket 1 and demo bucket 2. And next, each resource will be accessed based upon the index using count.index if you are using the count meta argument. Just always remember this. That is about basic explanation of the count meta argument. So we are going to implement practically this particular example as well. So this is a practical demo example for the count meta argument. So I have created one folder count underscore example. In that I have kept 2 files. One is main.tf, another one is variables.tf. First me let explain about this variables.tf file. What is variables.tf file? This file is used to keep all my variables. If you see here, I have 3 variable blocks here. Block 1, block 2 and block 3. So these are all the 3 variable types. All are of type string data type. So that's why first variable is of type string, second is also string data type, the third one also string data type as well. Next, first variable is used to declare my project ID in the form of string. That's why I have declared this default value as GCP hyphen training hyphen some numerical value. This is my project ID. Second variable is used to store my bucket name in the form of string. That's why I have kept my bucket name as default. This is my bucket name GCP hyphen demo hyphen bucket hyphen number. Third variable block is used to store the location of my bucket. So here my location is US, means it is American location. It is enclosed in double quotes because it is of string data type. Not only this one, bucket name also enclosed in double quotes, as well as project ID is also enclosed in double quotes because all are string variable types. The next thing is main.tf. This is my main Terraform configuration file. This file includes two blocks. One is provider block, another one is resource block. So provider block, why we use? We need to communicate with Google, right? Since we are using GCP cloud platform. So after provider double quotes use Google, it will communicate with Google. Inside this, I am going to pass my project ID by referring to variables.tf. How we can do that? Var dot project underscore id. If we use this, it will go to variables.tf and it will fetch this particular project id. Next one is the resource block. This resource block is used to create the storage bucket. We know this already. Here I have passed my meta argument as 3. Count equals to 3 means it will going to create 3 storage buckets for me, and this is my name of the bucket. In this particular format, it is going to fetch var dot bucket name. So this bucket name will be fetched from the variables.tf second variable bucket name. So this name will be taken into count. After that, it is going to attach index number based upon the count value. So it will start from 0, it will increment it till 2, 0, 1 and 2 because my count is 3. Index it will start from 0 and it will end with n minus 1, means 3 minus 1, 2. Next here location. Here it is going to store the location as US location and it is going to refer this variables.tf and it is going to fetch this particular US location. This is how this variables.tf and main.tf will work. Let me show practically how we can implement this using our Cloud Shell editor. Let's go back to that particular practical demonstration. Okay, so currently I am in Cloud Shell editor where I am going to implement practically the first count meta argument example. Okay, so here I have already created one folder with name count underscore example. Let me go inside that particular folder. How we can go count? How we can enter into that particular folder? Use cd our particular folder example, count underscore example. If we type ls here, I have two files, main.tf and variables.tf. So how I can show this particular content means cat. So if you want to check variables.tf, you can use this particular thing. Here in variables.tf, as explained, I have three blocks. One is for project ID, one is for bucket name, one is for bucket location. Let me show you main.tf as well. So if I use main.tf, currently main.tf having two blocks. One is a provider block, if you see here, for collecting the project ID. Another one is a resource block for creating the storage bucket. Here I am using same code, count equals to 3. This is my name of the bucket. This is my bucket location. Now what we need to do now means, let me implement Terraform in it. Okay. Terraform in it. So this what it will do, it will initialize all the plugins required for me. So I need to check whether my code is correct or not. I can also use Terraform validate to check my syntax, whether my syntax is proper or not. If you use a Terraform validate, what it will do, it will show your any errors in your code. So currently my code is correct and proper. So it is showing success. Configuration is valid, whatever the code that we have written. So since everything is fine, I am going to use a Terraform apply now. I am going to create three buckets with the help of count. Okay, let me pass yes here. Now what it will do, apply is completed, it created three resources. Okay, you can see here three resources are added, zero changed and zero destroy. Let's go back to our cloud storage. If you see here currently, there are no buckets here. If I click on refresh here, it is going to show us three buckets. Okay, see here GCP hyphen demo hyphen bucket number after that index 0, 1 and 2. This is how with one single code I can able to create three buckets with the help of count meta argument. So this is a basic sample demo for showing count how we can create buckets in the GCP cloud console. Let's go back to our PPT. So the next meta argument that we are going to discuss is about for each. For each also is used to create multiple resources, but it is somewhat better than count because for each provides more control and readability than count. And also for each always accepts only two data types. That is, it allows map data type and set data type. Other than these two, it won't allow remaining data types. Keep this in mind. So below is the syntax for showing the set data type and map data type for each meta argument. So the first one is for each I'm using here set of strings. In the brackets, if you see here item 1, item 2 and item 3. These are three strings which are enclosed in braces means it is a set of strings. So it is a set data type. The second one is for each I'm using here a map data type, which is always you know that right. Map always contains key and values. So key, this is the left side is key, this is the value, key and value. So this kind of data type also for each accepts and it will implement. Other than this, it won't accept any other data types. Let's see our practical demo session. In this particular session, I am going to use for each meta argument with the help of set. Means I am going to show you how we can use a for each with set data type. For this example, I have two variables here. One is main.tf, variables.tf. In variables.tf, as explained in before example for count, I have used the same three variables. Okay. So first one is string data type for storing my project ID. Second one is for my bucket name. But the difference is here, this bucket name is of type string data type, and also it is a set of strings. Means set of strings I am included in a set data type. If you see here, these are all the two strings, demo bucket 11, demo bucket 22. It is a set of strings. Okay, that is the only difference. And also the third variable is storing for my bucket location. This bucket will be stored in US location. In main.tf, similar two blocks are there, provider block and resource block. In resource block, the code will change. If you see here, I am using for each meta argument and I am going to fetch my bucket from the variables.tf. If you see here, var.bucket name, it is going to refer this variables.tf and it is going to fetch this particular bucket set of strings value. My bucket name, how it will be allocated this bucket name here. GCP, it is predefined as usual, whatever we have written, hyphen in dollar. It is enclosed as each dot key. Okay, what it will do? It will loop through key value. So here, these are the two keys. Demo bucket 11, demo bucket 22 are the keys. It is going to repeat this two times by using a for each. First, it will collect this demo bucket 11 value. Next, it will collect demo bucket 22 value. That is how it is going to print two buckets using this for each. And location, it is going to store directly from var.bucket location as it is. It is by fetching this variables.tf. This is about basic example. Let me show practically as well. This particular for each with string set of strings means set. So currently we are in my Cloud Shell editor. I am going to discuss about for each example which is having set data type. So I need to enter into this particular example, right? So use CD and use this for each example folder. Just click enter. If you type ls, I have two files here, main.tf and variables.tf. What I am going to do now, I am going to show you what is the content inside each file. Use cat.variables.tf. So in this variables.tf, I have three variable blocks here. One is for project ID, one is for bucket name. Here I'm using set of strings. Always for each accept set data type. That's why I'm using set. of strings, two strings I'm using here, and bucket location it will store as string US. If you see main.tf, let me see what is in main.tf as well. So in main.tf, as usual, there is one provider block, there is one resource block. But the difference is in resource block, I have used for each meta argument, it is going to fetch all the bucket by repeating through that variables.tf, and it is going to print my bucket name gcp hyphen with respect to each dot key. It is going to refer each key value which are listed in the variables.tf. Okay, let me clear the screen. Let me use Terraform init. So what Terraform init will do, it will download the required plugins necessary for us. Okay, so use Terraform init here. Let me use Terraform init now. So why Terraform init is used? To download the required plugins. Just use the Terraform init. So it will download the required plugins. Next, I am going to validate my code. So how we can validate our code? Terraform validate to see if any syntax or any errors are there. So currently my configuration is valid. It is well and good. So I can go and apply my Terraform apply code now. So just use the Terraform apply command. Just click enter. So just use this yes option just to create our resources. So currently the apply is completed. It is going to create two resources. So what are those two resources? Let's go back to our cloud storage and let's check that. Okay. These three buckets, what you are seeing, these are from the previous count argument. Okay. If I refresh the screen, it will show another two buckets. So see here, these are all the two different buckets. GCP demo bucket 11, GCP demo bucket 22. So if you see here, these are all the two buckets that are created using for each meta argument. Okay. This is about for each block. Okay. So in this third example, we are going to discuss for each meta argument with the help of map data type. To explain this, I have one folder created for each with map name. Inside this, I have two files, main.tf and variables.tf. Let's check each file one by one. In variables.tf, I have two variable blocks. One is for project ID. This you are already aware. The another one is for bucket name. If you see the difference here, this particular variable bucket name is of type. What is this type? Type equals to map of strings. Means it is a combination of strings, but it is a map data type. So map, how we will declare? We will declare in default block. Each map has a key and value. Logging is a key and US is the value. Application is the key and EU means Europe location. This is the value. Next, backup application is the key and Asia. This is the location. Here in key, I am storing three different names, logging, application and backup app. And in the value, I am going to store the location like US location, Europe location and Asia location. This is how we can store values in the form of key value pair using map data type. So in main.tf, I have similarly two blocks, provider block, we know already. Next one is the resource block. This resource will create the storage bucket, but this time it uses for each meta argument var dot bucket name. What it is going to do? It is going to loop through this variable bucket name. And first one is a name. It is going to print the bucket name using this particular notation. GCP hyphen dollar each dot key. What it will do means it is going to loop through each key. Like first it will loop through logging, next it will loop through application, next it will loop through backup app. So each time it will loop, it will take that value here in each dot key hyphen bucket. So it is going to print that bucket in this particular format. For the location, what it will do, it will use each dot value. It is going to loop through value each time. First time, for first bucket, it will use US location. For second bucket, it will use Europe location. For third bucket, it will use Asia location. That's how this particular resource block will create three buckets in three different locations. Let's see practically how we can implement this for each with map data type. To explain this for each with map data type, currently I have just logged in into my Cloud Shell editor. In Cloud Shell editor, I have created one folder with name for each with map. So we need to jump into that particular folder. Just use CD, just enter into that particular folder, click enter. In this particular, I have two files. One is main.tf, another one is variables.tf. Let me show each file once. So to show that, let me use cat command variables.tf. In variables.tf, I have two variables. One is for getting the project ID, another one is for creating the bucket. But here the bucket is of type map, map of strings. So each this map stores values as key and value pair. Already we have discussed. Let me show main.tf as well. Just use main.tf. In main.tf, I have two blocks. One is provider block, another one is a resource block. In resource block, I have used for each meta argument and I have used name and the location. So it is going to, for bucket name, it is going to loop through key. Each time it is going to loop through key. For location, it is going to loop through value. Like this, it will fetch each key and value from the particular map data type. Let me clear my screen. Just use our first command, Terraform init. What it will do? It will initialize the required plugins. Okay, so our Terraform init is done. Next, let's validate our code. How to validate our code? Just use Terraform validate to check if any syntax errors are there in our code. So our code is perfectly fine. Configuration is success. Let me go and apply. Okay, use Terraform apply command to apply our infra. After apply, it will ask for notification. Just use yes. It is going to create three buckets now. Okay, in three different locations: US, Europe, and Asia. If you see here, apply is completed. Three particular resources are added. Let me go and check my particular cloud storage bucket. See here, already 5 buckets are there. These are from my previous count and for each with set data type demos. If I refresh here, three. So if you see on the screen, currently I'm inside my cloud storage bucket here. So I have highlighted all the buckets created. So GCP application bucket, and the next one is GCP backup bucket, and the next one is GCP logging bucket. All these three buckets are created in a different location. So first one is created in Europe location. Second one is created in Asia location. Third one is created in US location. This is how we can use count and for each meta arguments. So these are all the buckets created as per our three different examples. Okay, that's all for today. If you like my session, please do subscribe, share my channel and like my channel. Thank you everyone.